it is my honor to introduce Souza Ono, who needs no introduction. He is the Director of Telecommunications Standardization Bureau. Please help me welcome Souza Ono.
Good morning, everyone. Let me start by thanking our co-organizer, UNESCO, for our long-standing partnership. Together, we lead the UN Interagency Working Group on AI, bringing together UN expertise to drive ethical, impactful AI. We need tools to measure our success. ITU studies have found key data gaps and inconsistency in how AI's climate impact are measured. This limits transparency, informed decision-making, and accountability. Yes. We are working on ITU standards to change that. Upcoming ITU standards will provide the frameworks to measure the life cycle environmental impact of AI. These standards achieves first stage approval just last week. It's the latest addition to well-established ITU standards providing climate impact metrics and measurement method. We are also working on standards for a new database on emissions and energy consumption. And we are now testing the feasibility of the proposed data collection framework. We are reinforcing climate action with our standards. And with our global competitions, we are crowdsourcing new solutions and supporting the next generation of innovators. We will recognize our latest winner in just a moment. To make breakthroughs for a better world, we need strong connections between technology experts, data owners, and experts in areas where new technology can drive sustainable development. That's why we continue expanding who engages with ITU's work with our AI for Good initiative and fellow UN agencies and standard bodies. And that's also why our activities at COP30 engage so many partners. Standards are the common understanding we all need to prosper. If you are not already participating in our work, I will encourage you to join us. You will find yourselves in excellent company. We have a global community that believes in commitment to collaboration and consensus. And this is exactly the spirit of we need to create the future we want. Thank you.
Thank you, Souza, and the incredible work that your whole team is doing on measuring what matters. I would now like to introduce Tomas Basikolo and Vishal Jain. These guys are going to showcase the highlights and the outcomes of the AI environmental footprint and measurement of the hackathon.
Thank you so much. Good morning, everyone. I'm going just to give a quick overview, so I will just run through the slides to show how we did the hackathon, and we have the hackathon winner here, Vishal. So the stage is his, but I just need to give a quick overview. So next slide, please. Sorry, take at the back. Can you help us for the slides? Okay, so the aim of the hackathon, we had a report called Measuring What Matters. And through this report, we came up with some gaps that we realized from the industry that we are missing to measure, monitor, and report the AI workloads. And from this, we came up with a hackathon in 3 subtopics on the carbon costs, the water usage, as well as just drawing out the measurement gaps. So through this hackathon, we had key solutions, and these solutions focused in different areas, as you can see. And we have realized that over time, most people are kind of concentrating on the carbon. But the water, there's not so much interest in water measurement. And the materials itself, the full life cycle itself, there's not so much interest in that. So these are some of the gaps that we have realized, and we wanted to close some of these gaps through this hackathon. So we advertised for this hackathon. We asked participants to give us these solutions through a report and a prototype. And of course, some had also code and a visualization dashboard, which you are going to see today. And this is quite interesting. We started in August, and we are here at the end to announce the winners of the hackathon in COP. So the evaluation was 6-fold, including the innovation, the accuracy of the solution, the feasibility, the impact, and the usability. And of course, we wanted them to communicate effectively their solution. And I would like to thank our judges who did a tremendous work to evaluate the solutions that we received for this hackathon. And the prizes, I would like to thank the ITU Global, the Green Digital Action for sponsoring the prizes. These are the ones that we have on the screen. And for the winners, the third prize is Eco AI Tracker. This is a team from Rwanda, Carnegie Mellon University in Africa. They did a tremendous work, and congratulations to them. The second one is Standardizing Energy Model. This is a UK-based student group that took the second prize. And for the first one is GreenMind. So I'd like to invite Vishal here, who is here. He's going to make a presentation, but maybe just a quick photo with our director, Onoe-san. Just a quick photo, maybe. So we are trying to be ecological. We are trying to be not polluting, not printing. So it's just a digital certificate. We are not going to print the certificate. Small steps, but I think they are steps in the right direction. Okay, thank you so much, and congratulations to Vishal. So you can come here, and I just wanted to come. Yeah, I'm going to leave the floor to you, but I just want to highlight that this is the report that we produced in July. But following the results of this hackathon, we are coming up with a new report that we are going to publish soon. Is closing the gaps in assessing the AI environmental impact. So we have not yet published the report. We are still working on it. If you would like to join us in shaping this report, please do join us. Take our contacts, and then we can keep in touch to make sure that we have a very good output from this hackathon, but also from this work on measuring what matters. So I'd like to give the floor to Vishal for his presentation. So you can switch the presentation. Thank you.
Thank you. Very good morning, everyone. I just landed here after 40 hours of flight time, but made it in time. So pleasure to be here, very humbled. And as Thomas mentioned, and as priority, I think 2 of COP30 this time is around making climate initiatives relatable to everyday's life of people. That's what we try to do in GreenMind. Making sustainability or empowering sustainable AI use. Going to the next one, we all know, no surprise, AI footprint, AI expansion continues to rise or rather explode. No surprise, right? But alongside is the impact on the climate and the negative impact. That's why we want to just make sure that we continue to keep an eye on the harmful side so that we minimize the harm and do the increase the good. Going to the next. The key point is that while I have been playing with AI every day in so many ways, so does my kids, and so is everyone here out there. But the climate footprint part is invisible. We don't realize how much is water, how much is energy, or the carbon is behind this. So our mission, going to the next slide, is making that invisible visible. And that's how we came with this product, an app called Samarth. Samarth means sum and earth. So that's one way to look at it. The smarter AI, better sum for earth. And the other one is sum in Hindi, where I come from India, means pure. So pure earth is another something which I relate to as well. So what are we trying to do here? Here, as a product, we are providing first-time visibility right from the prompt to tokens to the energy, water, carbon emission for an individual as well as for an enterprise. You can choose your persona. If you are an individual, you click there, go to the next one. And what it does is we are visualizing in the respective AI tools, the 30-odd tools which were assessed in the models. You can have a plugin. Right now, it's not a plugin there, but imagine that this is the screen of ChatGPT. You put your prompt. So step number one, you can optimize your prompt so that stage itself, you optimize your carbon, water, and energy footprint. And then you generate output. And as you generate the output, at the bottom, you see the carbon, water, and energy. Now, yes, I see that 23 ml water doesn't mean much, frankly. But when you try to aggregate, that becomes the whole new story. And that's what we are trying to do. Because first ever visibility around converting all this prompts and text and eventually video and audio into energy and the water consumption. Mind you that most of the AI companies have not been very transparent enough, not standards are not there. So we try to make an attempt and we use some of the research work to get to this stage. Going to the next, this is what as an end user you get to see for your week, for your monthly or for your yearly AI consumption. It sums total in terms of how much time you are spending on AI tools, what kind of a queries, text and image at the moment. And eventually it tells you about your water consumption and carbon and energy. Going to the next one. As an enterprise, imagine if at all an enterprise has about 300,000 people, if at all a rough math, that's where the power of aggregation lies. Because on an individual query basis, it could be 10 ml, 20 ml, 3 watt, doesn't matter. But when you try to aggregate it, this is the shell we created, that what it could look like for an enterprise when all employees AI use is aggregated. And then you start seeing the aggregated, very staggering number. That's where it can help to support the reporting, the sustainability reporting mandate as well as we go along, including we can provide the extract as well. Going to the next. And then we're relating into the equivalence, because it doesn't matter that how many water liter or what, how many, let's say 500 ml, let's say water bottles, 8.24 million water bottles, equivalent water you have wasted in the process, right? So that's what we're trying to do here. So the crux of the entire thing is, one is the front end, which we created, but behind that is the measurement methodology. There are 14 steps to get there. Right from the initial stage of conscious and smart querying, wherein from an end user, you choose whatever tool in the model, and it optimizes the prompt for the text and image at the moment, not video or audio or the codes. And the optimized model is then calculates the token. And based on the token, we are calculating the carbon emission based on the different factors, which includes the fundamental there is the latency, how much time it requires for a model to generate the query to the first end. And number two, how much time it takes in terms of to generate the full output. And based on that, we are creating the power, the energy, and then the water consumption footprint in water, both on-site and off-site combined together. And then finally, we combine that to aggregate for the end user and for the enterprise. So that's the crux of it. I do have slides to go through each and every step there, but that's the message to me that you're taking too much time. Maybe just go flip few slides. We just did create, just keep flipping. So we decided in terms of the how do you really get to this. So behind this dashboard is all number of steps behind this. But net, what we're trying to do here is, again, we took inspiration from an ancient concept called unearth done, which means that minimize those actions which are unnecessary and may cause harm directly or indirectly. How do you minimize if you're not even aware? And that's what we're trying to do, that make that invisible visible so that more people are aware, more they become conscious, and more they steer towards the right steps. Going to the last one. Next one. Maybe I skipped one. So anyway, that's what we are. So we formed a team. In my professional capacity, I'm in a very different background. I work in a Fortune 500 company as managing director, but this was a personal pursuit of trying AI to create something what you feel passionate about. So when we say AI for good, here is an example of how AI is democratizing. So the product is created without any coding, just by AI tools called vibe coding. And that's how we came to this stage. So that's where we are, and very privileged and very honored to speak to you all. Thank you so much.
Perfect. And congratulations, Vishal. It's really exciting to see someone who is an executive already working in the field coming and spending the extra few hours they have in the evening putting together something as beautiful as a project as this. All right. I now would like to introduce the panel. We are going to be measuring and managing AI's environmental footprint standards, tools, and collaboration for sustainable innovation. I would like to invite our moderator, Jean-Manuel Canet, who is ITUT's Study Group 5 reporter for Question 9. And I would like to invite Paolo Gemma. He is the Senior Standards Expert. And please welcome Adam Elman, Director of Sustainability, EMEA with Google. Rob McGreevy, Chief Product Officer with AVEVA. And please help me in welcoming again, Vishal Jain.
Many thanks, Alayna. Many thanks to dear panelists for joining this morning, and many thanks to the audience for coming here. That's a remote place here in the COP, so you managed to come. That's great. That's already a great result. And so we will now immediately start discussing how to make visible the invisible. And I would like to kick off asking you a question, Adam. You're from Google, very well-known industry leader, and we would like to hear from you whether today big companies offering AI solutions, do they actually assess the environmental footprint of AI systems, and how do they do it? How do you do it?
Thank you. Great question. Good morning, everyone. Thank you, ITU, for hosting this important discussion. I mean, I think the first thing to say is, I know obviously ITU with Etsy and Jean-Manuel, you're obviously a rapporteur, are doing this really important work in terms of building the frameworks to provide the guidelines for really measuring and assessing the impact of AI. The challenge is that doesn't exist today. So at Google, we've really taken the own initiative to really build what we think is a comprehensive approach to sort of doing this measurement. And importantly, not just sharing the final figures, but the detailed methodology that we believe is appropriate to sort of support these figures. And really sort of two areas we've sort of looked at. So I think firstly, looking at the full life cycle, really important you don't just sort of focus on the operational use, but really focus on the full life cycle. Earlier this year, we published a full life cycle assessment of our AI accelerator, so what we call our TPU, the Tensor Processing Unit. This is the silicon, the chip that is powering our AI, and really looking at a comprehensive approach right through from raw materials through to the operational use. And we've, as I say, we've published that. There's a full methodology online. You can Google it, and you'll be able to find it. So really important that you look at the full life cycle. I think the second thing is really looking at the full serving stack. Again, this is making sure you're accounting for everything. One of the advantages we have as a Google as well is we don't just look at sort of the theoretical, i.e. an average is this multiplied by that, but actually we can look at the actual operational use, what happens in the real world. And we've done this for Gemini, which is our core model. Hopefully you're aware of it and have used it. And we've published the medium figures from a Gemini text prompt prompt, looking at what the water use, the emission use, and the energy use is. And actually, again, if you read the media, you would think that AI is sucking up all the world's energy and resources. So it's important we put the facts out there. And to put it in perspective, and a medium Gemini text prompt is about the same as watching 9 seconds worth of television in the US. And again, we've really looked at every aspect of it. So not just, for example, the TPUs, but we've looked at the CPUs, we've looked at all of the operational emissions and impacts that go into running a data center themselves. So again, really looking at the full life cycle. And again, we've published all of this information in a detailed methodology. So yes, we're doing that measurement. We think it's really important. And we also then think about how we can use this. So what is the purpose of these? So for example, if you're a Google Cloud customer, we have a portal. You can go on, we show the emissions associated with running on Google Cloud. And we also then give you tools you can use to shift workloads to different regions and what have you, again, to reduce your impact. Final thing I'll say is we've just released just last week a guide called Build Sustainably, which is really aimed at software engineers and developers, giving them the insights. How do they build their models, their tools, so they can have, reduce impact as much as possible? So hugely important. And we also then want to obviously, we're very actively engaged with the work you're leading, sharing our knowledge as well in this space.
Yeah, thanks very much, Adam. And the participation of Google and other industry leaders is very important in order, let's say, to develop an appropriate standard in the field. Thanks so much. I would like to question you now, Vishal. Again, congratulations for this splendid victory. So we have seen about the difficulty, let's say, on assessing the environmental impact of AI. Which gaps have you found in the assessment of this impact, and how did you handle that when developing the solution you have developed? Would have to up.
Yeah. Thank you. So first of all, it was a realization and a wake-up call that so much AI has become part of daily life without we realizing how much is the backstory of environment, which was the biggest self-realization I myself had. I started calculating my own AI consumption as well as environmental footprint. So the biggest gap we saw was that, at least to our knowledge, there is no place where one can see a view in a standard manner of carbon, water, and energy consumption. Yes, Google published something, AWS published something, but these are not standard. And that's what I think AI for Good try to really have the standard set. That was the first realization. I think in terms of the gaps, water is, as Thomas also mentioned, is unexplored area in terms of water on site as well as water at the source, which is to generate energy, how much water is consumed. So that has been a gap itself. And then, of course, there's a complete, then scope 3 about the complete supply chain and all that is not measured. So those are the gaps there anyway. I think other thing is that in AI, while text is a lot of exploration, but image, how much image could cost? An image could, estimates have been very varied in terms of how much image would equal to the prompts and the tokens. And when you think about now video and audio, as well as now people are developing apps like we did, I'm not sure how much consumption it has led to, or of the AI or the water and the carbon. So those are the gaps which are there. In our case, we did rely on research done recently by some of the students of University of Rhode Island. So we collaborated with them to leverage, because that was the first attempt from their side. And I want to give credit to them to at least make a start. Otherwise, we keep waiting for perfection. There's not going to be any perfection. Progress over perfection is a theme I live by, and that's what we try to attempt here.
Thank you. Thank you so much. And according to you, what would be the most difficult part?
Most difficult part would be that, first of all, making people realize that it matters. See, as I said, it's only 15 ml or 9 seconds, as you mentioned, equal to TV time, right? I think the real thing is in aggregation. So the user emotional code is not struck till the time you really aggregate and really make them aware of the broader footprint. So the most difficult part is making people realize that, hey, everything matters. Even if it's a 9 seconds or 20 ml, that matters because it all adds up. And that's why we came with the name Samarth, sum total of your AI footprint.
Thank you so much. And how do you believe solutions like the ones that you developed could be scaled up and implemented at scale?
That's the biggest question, because prototype is a prototype. And I work in Accenture. There's a long journey from prototype to the actual usage, right? But I guess democratizing AI is democratizing so many different ways. And that's how the discussion and the conversation here could really lead to collaboration, right? And that's how we take it forward. So that's just, that's what I think about it.
Okay, thanks. Thanks so much, Vishal. Question back to you, Adam. In your opinion, assessing the environmental impact of AI for Google, is it more like, let's say, a compliance topic, or is it more a strategic move?
I think you've answered that already. I mean, it's a strategic move. I mean, I think compliance in some respects is backwardly looking. It's interesting, but actually the real advantage, that strategic advantage, is being able to do things that are forward looking. And I think there's sort of two real aspects to this. And you just touched on this to some degree. So yes, for example, we've measured the medium of a Gemini text prompt, 9 seconds and 5 drops of water, etc. That all adds up. But what's really helpful for us is having that insight that then helps us, it helps our engineers figure out what are the changes they need to make out. How do we optimize for different grids? What are all those different things we can do to make ourselves more efficient? By the way, important for the planet, but these are huge costs for us as a business. So there's a huge business imperative and reason to do this. To put it in perspective, when we did the Gemini measurement, over a 12-month period, we reduced the energy and the carbon by 33x and 44x. So, we're able to measure, we're able to take those actions to have a huge impact. I think the second area is then about building trust from our user base, from regulators. So, Google users are interested in this. How do we give them the information so they can then make informed decisions? How do we help inform policy and standards? The reason we can show up and be a key player in your discussions is because we've done the work, we've done the thinking, and it's really important for us that the standards and the policies, I mean, I cover Europe, Middle East and Africa. Europe's doing a hell of a lot in terms of the AI Act. So it really enables us to engage in this space. So I think for any organization, I'd encourage you not to think about this from a compliance perspective, but how do you really do this as a strategic imperative and a strategic advantage?
Okay, very interesting. Thank you so much, Adam. So you just spoke about standardization. Let's have a short discussion about standardization. And I would like to ask Paolo, who is one of the leaders in the standardization efforts in ITU and also in other bodies. Paolo, according to you, what should be prioritized when developing standard on the assessment of AI impact? Should it be, for instance, on the inference phase, training phase? Should we prioritize the assessment of GHG emissions, energy consumption, water consumption? How do you see that?
Thank you for this answer, but I need 1 week to answer, I think, not 5 minutes. I think that as we made in the standard that we just approved consent less than 1 week ago, and it's the L1801, if I remember well. And the idea is to look in reality in all the phases of AI. Is a little hard at this stage said, okay, which is the more impacting phase. This depends also on model of AI. A lot of people think on training and so on. I think that we need to, as we made it, as usual, look in all the phases, not only in one, because we don't know in the future will be the first part of the impact on that. Sure, what we see is that there will be a very big impact on data center, because there is some prediction that give a crazy number for data center to arrive at 1 megawatt for cabinet. That means the actual data center are not able to live. So we need to have a new solution, new technology solution. I think that as ITU, we need to work to standardize some solution, some maybe new KPI. Especially, I know that we are working on software efficiency. That is something that is very important because when I speak with people more expert than me on the AI, but is really what all the training that AI is doing is correct, or maybe can be simplified or not. And the answer that I receive sometimes is yes, no, I have no idea. So I think that we need really to have KPI, as also he said by him, to give a guideline to the people that make the AI tool, on make the right tool, thinking on the impact, not as we made in the past for our technology, that we make the tool, then after we look on the impact and nothing change at that point, because when you have realized the routine, you never change. And this, I think, is the next step for standardization. Really look on detail on what will be the way to optimize AI to try to reduce the GHG emission and energy consumption. I think maybe on Gemma, don't agree too much with me, it's important to reduce the energy consumption before the GHG emission. Because to reduce GHG emission sometimes is easy. You buy renewable energy, you cut off your GHG emission, but it's not the right way. You need to be more efficient on this.
And all starts with energy. I can only agree with you.
Yes.
Sure.
Because I remember some report from EEI, from International Energy Agency, they said, sorry, will be no renewable energy sufficient for all.
Yeah, and it's associated to cost as well, obviously.
Cost, okay.
Okay, thanks very much, Paolo, and congratulations for the consent on this standard last week. And a question here. So this standard has just been consented. This is the first step towards approval. In your opinion, Paolo, what could be done to ensure that such a standard is adopted, is used by the community, by different companies?
Sure, we need to spread the information on the standard. I hope the company like Google and other company start to use the standard to give us also feedback, because we know very well, and I know that we are not perfect. Maybe we can improve something on the standard, but we need to have feedback from the user. And another point is I like what the result of this hackathon, because it can give the visibility to the user of AI on which is the consequence of that they make. And if the people have an idea on which is the consequence of the action, maybe they look to a better step to look in a standard to have a detailed overview, a detailed assessment on the AI. As ITU, with events like this and other, we spread the information of our standard. The standard is made in collaboration with the European Telecommunication Standard Institute, that is one of the European standardization official from European Commission. So we hope that also in Europe, maybe European Commission push to use this standard.
Thanks so much, Paolo. We know that there are also other initiatives regarding standardization of this kind of impact, like in IEEE, ISO. So how could we ensure that there is no conflicting, let's say, documents, and we avoid to have a conflicting patchwork of standards?
As okay, my no short experience standardization, I think the only way is to speak between the standard organization, to exchange a document, to try to align. What ITU is made with ETSI was very fantastic, because we practically publish the same standard with different logo. With our organization is a little more difficult, but we need to try to find a way to speak together just to avoid to have conflicting standard, because this will be a very terrible thing. Have only one standard from all organization, or a methodology that is similar for all organization, I think is our goal, and is what we need to do in reality.
Thank you so much, Paolo. So let's now speak about industry action. And I would like to ask you, Rob, you're from AVEVA, which works at the intersection of AI and industrial decarbonization. I would like to understand how are your customers using AI, and have you started to assess the environmental impact of such a use?
Yes, thanks for the question. And yeah, as at AVEVA, if you're not familiar with our group, we work in critical infrastructure. So like power, water, we consider data centers there as well. And then a lot of the industrial manufacturing. So anybody who makes or manufactures finished goods. And for us, look, we've been using AI at scale for quite a long time in that industry with quite positive outcomes and results. First thing I'll point out too is that what I would like to say is that not all AI is sort of created the same. There are certain compute models like foundation models and such, which are quite CPU intensive, but there's a lot of machine learning and first principle models that do not require as much compute, but have significant demonstrable results in manufacturing. And I'll talk a little bit about data centers. And when you think about just energy load, reducing 20% of the electrical usage in a specific facility or plant can have enormous impact on sustainability. You're thinking about data centers, the cooling and heating abatement alone is like 87 gigawatts, something like that in the US. And so having a 20% reduction off the bat by just using AI to actually mitigate AI is actually quite compelling. And I would just say that across all of industrial manufacturing, we see a lot of significant cases where this has sort of come to the foreground. Companies like Enel, large utility companies that are trying to provide more power at scale for data centers and for industrial processes have had enormous savings in water, air, gas, steam, and electricity. 10 to 15% savings in water reduction, upwards of 20% savings in electricity by applying AI models, and literally documented cases of hundreds of millions of dollars in cost avoidance by using predictive and prescriptive models to look at forecast models that look at preventing outages for things like storms or fluctuations in the grid. So we've seen quite a bit of AI, I would say very specifically in industrial manufacturing, that's having a very significant impact on environmental footprint. And of course, the last one I would say is that when you bundle all those up, you actually can start to get quantifiable benefits in CO2 savings, right? Because these models can also predict the most optimal machine configuration for producing power or running a process, and then reduce, tens of thousands of tons of CO2. So that's probably like one major area that I would say that we see in industrial manufacturing. And there's quite a few other ones as well.
Oh, that's great. Yeah, Adam?
No, sorry, just briefly building on that. And I think there's a lot of research. The IEA put out research. Lord Stern and Grantham have put out research recently highlighting 5 gigatons worth of emissions reductions, 3 to 5 times more than the impact of data centers and AI itself. So we at Google think there's a huge opportunity, and we're certainly invested in building the tools and solutions, both mitigation, but as you touched on, adaptation and resiliency as well, whether it's flood forecasting, wildfire detection, hurricane forecasting. So there's a huge opportunity, but we've all got to do it responsibly, which is why obviously the work we're talking about here is so important.
Yeah. Thank you. Thank you so much to both. And Rob, a complimentary question. Do your customer actually, do they report the benefits that they have, and how do they do that?
Yeah, exactly. So those statistics I cited are all documented customer examples where they're actually capturing, collecting high fidelity data about their processes, running calculations, and then reporting the results. Another example, I know I mentioned Enel Energy. There's a bunch like Duke Energy in the US. Many of our customers that do power obviously report these metrics. And then even here in Belém, Norsk Hydro is a facility here running in Belém that uses our software to capture water flow rates, and they use it specifically for what they call an EMS system. It's environmental monitoring system. And what they've been able to do is capture all this data, put this in the hands of their operators, and then they're able to drive optimizations, which results in using less fresh water. And they achieve that by pumping less water and doing things like looking for leak detection. And when you pump less, you use electricity, and obviously so you can save water and electricity. The net effect too, by the way, is not only a win for the environment, but I think Adam touched on this, or maybe it was Vishal, but there's a quantifiable business return. I mean, when you reduce water, steam, air, gas, electricity, and other feedstocks for manufacturing and critical infrastructure, there's a huge impact on profitability and bottom line. And then obviously there's quite a win for the environment as well. So there's kind of both a planet wins and businesses win at the same time, if you like. And if I may, one last point, we talk a lot about just the generational impact of this. So in manufacturing and critical infrastructure, there's quite a few, how do I say this, later generation or later career individuals where there's a lot of retirements and a lot of tribal knowledge, expertise in manufacturing is sort of, well, they're retiring. And so how do we enroll the next generation of workers and empower them to use these tools and technologies to run facilities and reduce emissions impact? And so AI actually has a great role here. We work with companies like Covestro, for example, where they use simulation and modeling to train new engineers on how to best design manufacturing processes or operational processes like in data centers to actually design and build them for the most efficient use of resources. And they do that using AI tools, first principles, PIN models, things like this that all sort of enable it. So it's kind of a really unique sort of win where a lot of the industrial value chain can have a great impact on sustainability using AI.
Yeah, many thanks, Rob. Very interesting. A question back to you, Adam, on transparency and reporting of the own footprint of AI systems. How do you, according to you, what are the challenges of that? And how do you somehow balance between transparency and competitiveness?
It's a great question, and there are several aspects to that. I think one is this this piece around comparability. What are you measuring? I think you touched on this before. When we think about water, we use water to cool our data centers, but then there's water in energy generation, and so I think having the sort of context around measurement. Part of the reason we publish the detailed methodology is you might disagree with how we've done it, but at least you can see what we've included, what we haven't included, and why, and then we can have a discussion around it. And this is why the standards are really important. So sort of context is really important. And of course, this is really important so people can make like-for-like comparisons. Otherwise, someone may say, Google you're bad or Google you're good, but it might not be a sort of like-for-like piece. I think the second piece is this sort of balancing transparency. And we've always sort of tried to lead with transparency. We were the first hyperscaler to publish our water footprint across our business, and obviously now taking that down to the sort of AI model level. But we obviously need to balance that with proprietary information. So often what we will provide is sort of aggregated data with the methodology, protecting our sort of proprietary or other information which would give competitive advantage to others. So I think that's always a balance. Ultimately, our goal here though is how do we raise the bar across the whole industry? How do we try and lead from the front, work with others to set standards so the whole industry can improve? But it is a careful balance, and one that again, we're very lucky. We get to work right across the business. So we bring in all of the relevant teams so that what we end up with something is the entire business supports and that we can build from.
Yeah, many thanks, Adam. Paolo, please.
Yeah, I think that the scope of a standard is just to give a common methodology, to give the same methodology to all the company, to have a transparency and a fair competition between them. And this is the scope of a standard. And we hope that the standard that we have just approved go on this way and help to have a transparency between all the company. This is our scope.
Sorry to come back in. Just one more point. And I think this is where it gets quite challenging. Take water as an example. We have data centers that use fresh water. We have data centers that use seawater or canal water. In certain parts of the world, water is a real problem. We've just opened a new data center in the UK. It uses air cooling. Water is an issue in that situation. It was the right thing to do. Other parts of the world, water is not an issue. So actually, is high water usage an issue or not? Well, it depends on the context in where the situation is and what type of water you're using. So all of these things require careful thoughts. Otherwise, again, we're not measuring on a like-for-like basis.
Thanks very much to both of you. A question to you, Vishal. With the prototype you have developed, how do you think such a prototype could be used to improve transparency at, let's say, at industry level?
Certainly, as users start using whichever way, let's say no standard is a standard one. You can always keep debating, like Google publishes something and Meta publishes something else. But the reality is that as we start using, we start evolving together as a community. So the way we attempted this is this can be a plugin to an existing user journey. So footprint is measured, it aggregates, it makes you aware. And even for an enterprise having hundreds and thousands of employees, they get a combined reporting and visibility. And that's how one can then always have a degree of error of maybe 15-20% to begin with. Like it's the same time of airline emission, maybe 15 years back, how we got to a more standard space. I think it's the same evolution I see. But the point is start making it visible to have a dialogue and a narrative around it. And more we aggregate, more users are aware, more enterprises are aware, more they question the enterprises, the tech companies to have better standard and more transparency.
Thanks very much, Vishal. Just a question to the organizers, because we started at 9:15 instead of 9. Just how much time do we have just to adapt? Can we finish at 10:15 or no? Okay, so I will go quicker. 2 minutes finish? Okay, good. So thanks a lot for all these views. And so I will ask 5 minutes. Okay, 5 minutes, that's better than 2. Thank you. So let's, I have 2 questions more for all of you, let's say. The first one is, imagine in the future, there is for every AI model, a sustainability data sheet. What would you recommend that should be in this data sheet, let's say?
From my point of view, I see an average of the emission of the operation that I made and the energy consumption. This is a little complicated because it's a linked of where the routine is, in which data center, and so on. But something an average would be very nice, I think.
Thank you, Paolo.
I think there's always a desire in this space to simplify, and simplification is good to a degree, but we need to make sure we don't oversimplify, and we've already touched on some of the sort of issues as to why that's the case. I think, though, we do need to be holistic. I think energy is really important. I think carbon's really important. I think water's really important. Certainly when thinking about carbon, again, that can bring in a lot of the other aspects from raw materials, manufacturing and what have you. So I think certainly those are the key aspects we focused on within our model. So I think holistic, without trying to simplify too much, because we risk then actually losing a lot of detail.
Thanks so much, Adam.
Yeah, and from my perspective, just to add on, to build on what the gentleman mentioned here, in our world, like all of our data comes directly from verifiable sources, sensors, control units, PLCs, RTUs, DCSs. There's a whole world of this equipment out there. One of the things that we do is specialize in extracting the actual raw values from these pieces of equipment and then documenting that source, where it came from, what time it was taken, how accurate it is, how reliable it is, and then we store that and we can make that available. So for me, I would say the veracity of the information that's being used in the calculus that Adam and the team mentioned here, I think would be critical for that, because it helps give people transparency and confidence that this is the data, here's where it came from. And as you said, like people can argue about, you know, the rubric or the methods you use, but you put it out there. And so in our case, since we have access to all that high fidelity process production data, if you make that available, it's another proof point that the data that you're actually whether it's consumption or electricity, it's actually the real deal.
Thanks very much, Rob. Vishal?
I think the panel already covered so many aspects. Maybe if I can go a bit off topic, if I wish, it can also measure the time people are spending on AI, because AI is democratizing so much, people are getting into so many trivial things or unnecessary things. So as an enterprise, while it is saving time, but where is the time going? Maybe there is a extra time going in experimentation. So again, that's not sustainability, but somewhere indirectly, more time people spend on this tool also leads to the more environmental footprint and more time going from their personal time as well. So again, that's just my personal point of view.
Thanks so much, Vishal. Paolo, please.
I think that just to complement what we said, I think we need to think to have different information on depending who will be the user of that information. I think simple information for consumer is something. Then there will be more detailed information for authority and so on is okay. And what he said, there is not about what we call rebound effect.
Yeah.
It's very important to try to avoid that people spend their life in AI, because this is, especially for young generation, is very important, I think. I don't want to have a disclaimer, please take care that they create a dependency like a game, but maybe something similar should be nice.
So this will be the concluding words. Thank you so much to each of you. It was a really very interesting panel. Thank you so much to the audience. Thank you for coming and listening. We had a great time together. And so with this, I would like to give back the floor to Alayna. You are here.
Thank you, everyone. What a wonderful panel discussion. And I think that we can all see, by aligning innovation with measurable impact, that we create the true framework for progress that lasts. I would like to mention to everyone that if you have interest in measuring what matters paper from ITU, please reach out to Tomas. He will be willing and very able to help you guys reach out with this paper. Thank you so much for joining us. Congratulations again to Vishal, and I look forward to meeting you guys again in the future.